Hey guys, I'm Han, a 15-year-old machine learning developer currently focusing on replicating different neural functions using AI to push progress towards artificial general intelligence. So I started out the month by evaluating different hypotheses that I could come up with using my previous knowledge in neuroscience and machine learning to make the status quo ML models more replicative of a human brain. And when that approach stalled, I realized the best way forward to generate as much thought leadership in the space, as well as expand on my technical abilities, was to build a physical project. So I decided to replicate a human's ability of continual learning, which is essentially when we can apply any previously stored knowledge to an unforeseen task. This is done using a series of neural networks in a framework called Deep Generative Replay, which was initially proposed in the paper visible on screen now. How this approach works is that for each different task, you have one generator and one solver, the generator being a WGAN and the solver being a simple CNN. So in my project, I had two tasks. One is image classification on the MNIST dataset, and the second is image classification on the SHVN dataset. So when I'm training the first generator and the first solver, I train normally loading the data from the direct MNIST dataset. But when I'm training the second generator, the first 50% of the data is from the relevant SHVN dataset, but the second 50% is actually the generated MNIST images, which are the outputs of the first generator that we trained on the MNIST dataset. Similarly, when training the second solver, the first 50% of the training data is from the relevant SHVN dataset, but the second 50% is actually the generated MNIST images from the first generator, then run to the first solver to generate image labels, which can then be used as training data for the second solver and final model. So the final model achieved a staggering accuracy of around 90%, which is incredible compared to the status quo, because the status quo, if you were to be able to train on two different tasks, we'd achieve really high accuracy in the first task, but then the accuracy immediately drop when it comes to the second task. But this new model using Deep Generative Replay allows us, when tested on both SHVN and MNIST datasets, on a single model, achieve incredibly high accuracy of 90% on both of them. So feel free to check out the GitHub repository with my full code, as well as a Medium article breaking down the intuition, the trading pipeline, as well as a code walkthrough, both linked in the description below. In any other news, me and a group of friends are going through the Mathematics for Machine Learning textbook, which we found is the best way to consolidate all the knowledge and math prerequisites required for building really low-level machine learning models and algorithms. And we spent the majority of this month going through a linear algebra section. Now, super exciting news in the month of February is that we're actually working with a leading company in the energy sector to solve different problems and incentivize economically, and pitching to them at the end of the month. So my main goal for the month of February is just to devote all my time and energy into leveraging this opportunity, and then I'll return to my machine learning and neuroscience work afterwards. Catch you guys next month.